Welcome, everybody. I'm very happy about the lively interest in this webinar. I first want to introduce myself. I'm Patricia Pscherer, the Alignment of Standards Manager at Carbon Standards International, and I'm leading you through today's webinar about the Global Construction CSync. The Global Construction CSync standard is the latest standard developed by the Ithaca Institute and hosted by Carbon Standards International, and its pre-release is currently in the public consultation phase until April 30th, so the end of this month. At the beginning of this webinar, I would like to take a chance to introduce you to the structure of the webinar. We are going to get 3 input presentations by our 3 speakers, Hans-Peter Schmidt, Uli Steiner, and Andi Kehl. And they will last for 20 to 30 minutes. And after each presentation, there will be a slot for questions that are specifically referring to the topic of the presentations. So the order of the presentations that we have today are the introduction to the Global Construction CSync standard by Hans-Peter Schmidt. He's the founder and director of the Ithaca Institute for Carbon Strategies. Afterwards, Uli Steiner, the founder and CEO of Carbon Standards International, will tell us how the Global Construction CSync standard is applied. And last but not least, Andi Kehl will talk about the first building, business models, and initial experiences with the Global Construction CSync standard. He is the founder and CEO of Openly. And once again, it's very, very nice to have you all on the webinar. And I would like to give the floor to Hans-Peter now.
Thank you, Patricia. And I will share my screen. And if you can all see the screen, I will start.
Yes, we can see
Patricia? Okay, good. Yeah, thank you very much, Patricia, for the introduction and for everybody to be there. We are happy and a little bit astonished about the interest that this construction standard finds compared to other standards that we developed, like for tree plantation or enhanced rock weathering, where there was significant less interest in the beginning. So it seems that this is something that's in the mind of many, and that was also the reason we decided to go for it. You probably know, most of you know, that we worked for a long time already on the inclusion of biochar as a building material, and within the Global Biochar CSync standard, constructions are already accepted as a sink, as a carbon sink for biochar. But now it was time to develop a standard that includes all types of carbon that comes from the atmosphere and get included into the construction body. And this is the standard we developed for this purpose. Okay. So there's a funny thing, and you see a very nice sink building here. That, in fact, since the first ideas about certifying carbon removals from biochar, but also from soil organic carbon, we used carbon sink as the terminology for it to describe that the carbon is sequestered at a location, at a defined location that's physical, that's touchable, And we use since then, so this is more than 10 years, the word carbon sink or sea sink to describe the sequestration of carbon. And in German Kohlenstoffsenke oder auch Seesenke. And we were a bit surprised that most of other standards and traders and people in this business, they prefer to stick to the terminology that initially comes from the Kyoto protocols and in avoidance of emissions, something like negative emissions or carbon dioxide removal. So the removal is the activity to take out the carbon dioxide of the atmosphere, which the tree, for example, would do. But the carbon sink is now the certification and verification that this carbon is sequestered. So this is not about only the action. The action of the removal is the beginning, and the sink is what in the end matters. So how much carbon is stored outside of the atmosphere. So we use carbon sink, and then Elon Musk brought the sinking back to X, and now we have the sea sink, and as you can see, you can also make K-sinks, and that's why American and British colleagues don't like so much, because they think about sinks and not about carbon so much. So that is a kind of short introduction why we use carbon sink, and we stick to it because we think it is the right terminology for all our standards where we certify the carbon that is stored as at a defined location. Now, if you already looked to the standard, you will find this diagram that we cite and referenced in the beginning, and which is so fascinating and in fact incredible. And you find this is the so-called anthropogenic mass. That means that is all those materials that, let's say, went through a human hand or the human intention to build something. So these are all the materials of the so-called built environment. And most of it is concrete and aggregates, and bricks and asphalt. And then a significant amount is also metals, and it's tiny for all the rest of it. So this built environment became a bigger mass than all the biomass growing on Earth in 2020. And this is an exponential curve that's not ready to stop. So you see it's going up and up and up, and it's expected that already in 20 years from now, it will double again. And it will add to the built environment as much mass as biomass is on Earth just in 20 years. It's incredible. So, not judging about it, just taking it as a fact that so much materials will increase the built environment in the next years. So we calculated if only 20% of these materials would be replaced by biomass-derived materials, that means by carbon materials where carbon was removed from the atmosphere, that would make already 400 gigatons of carbon sinks in the next 20 years. And as we know, we need about at least 800 to 1,000 gigatons until the end of the century. to compensate the legacy emissions and keep global warming below 2 degrees if all emissions are reduced, then we know this is super significant. In fact, we could probably only with the built environment, only with materials that we built onto this globe, if we use natural carbon materials, we could stop climate change only with the building industry, which seems just incredible. But that's are the numbers. So that shows also why working on standards to certify these carbonaceous materials in the built environment is so important, and probably also evoked your interest. So how does this standard work? In a certain way, it's pretty simple. And then there are the details that make it a bit complicated, and where we need to work, as with all standards, in fact, to make the details work without becoming an overburden of the entire system. So you have, like, as you can see here, 5 kind of units of the standard. And the first unit is where the removal happens, where the carbon dioxide gets out of the atmosphere. That is where the biomass carbon is built or is grown. So that may come from forest, which is what people think in most cases about organic carbon materials in construction. So that would be wood. But it may also come from farming, like straw materials, or like bamboo, or like other fast-growing biomass that can be compressed into building materials or transformed, for example, through pyrolysis into building materials. So this entire sector of biomass is part of the certification scheme, and you will see how this works. So that means we have to look that this biomass is produced sustainably, and that all emissions caused by the production of the biomass are accounted for. Then from the biomass stage, usually there's a processing stage. So for example, if you have straw and you include the straw into bricks, then you have the processing of the brick making, where part of the brick material is carbonaceous. So this processing step has to be documented, has to be controlled, and all the emissions caused by the processing steps has to be accounted for. And then you may transport it directly from the processor to the construction site, or there might be traders in between, but you have always transportation of the materials. So from the biomass production to the processor, from the processor to the trader, trader to the construction site. And then we have the construction site. And here it becomes interesting, because now we have carbonaceous or carbon sink materials. Let's say we have a brick with biomass in it, or we have wood, or we have wood beams, or we have biochars. So all these materials containing natural carbon will enter at the processor site into the material index. So this is like a big database where all information of the material itself, then the units of it. So if you have brick would be a unit, or a beam would be a unit, or 20 cubic meter of concrete would be a unit. So you have the material in the material index, and we will see what information that requires. And now all materials that come from the processor, they have an ID. So normally that would be like a QR code or an RFID chip. So something that you scan at the construction site. So now the material comes at the construction site, you scan it, and you put into the application the amount of it that you use and where in the building you use it. And then we have it already in the construction unit. So the construction, every construction like a house or a bridge or whatever you build is becoming one unit. We know where in the unit the carbon materials are integrated through scanning each material when it comes into use. And then this carbon unit will be registered in the carbon register with all different carbon materials that are included in this building. So this, you would not, for example, register the bricks in the building or the concrete in the building. You register the building with the bricks, with the concrete, with the biochar, and with all the wood. And you would also have the emission portfolio of the C-Sink unit, so how much greenhouse gas emission were caused to build this building. And all this will be found in the global carbon sink registry. And then we have our construction C-Sink. So this is more or less the certification. We could stop here and think all the details are described in the standard. But I would like just to go through certain of these details that help to lead the discussion later. So again, as I introduced, the C-Sink is something that you can touch. It's something that you know where it is, something you know when you put it, and something when you will look for with analytical methods, you will find it. So it's a measurable unit. And the certificate guarantees that the sink is where it is supposed to be and with the amount of it. So, as I said also in the beginning, a carbon sink essentially consists in three distinguished things. So the first one is it comes from an active removal of carbon dioxide from the atmosphere. So a sink is not that you find some carbon somewhere and you put it somewhere where someone looks over it. If you don't have the tracking to the moment when it was taken out of the atmosphere, the sink is not complete. So part of the sink is, and it starts with the active removal. Usually the carbon that you remove from the atmosphere, and in the atmosphere it's in CO2, and in most cases the CO2 is transformed into another form. It could be into lignin, it could be into cellulose, it can be into biochar, it can be very different carbonaceous molecules. It has to be a storable form. So you have a transformation step of the CO2 into a transformable form, And then you have the verifiable storage outside of the atmosphere. And that's essentially what in all of the standards we follow. We go from the removal from the atmosphere to the sink. So some short facts to repeat also what we introduced already. So we track the carbon from the biomass production site to the construction site. So this may seem an overburden, you know, if we would need, like, for every brick an RFT chip and track every kilogram of sand from the beach to the construction. This has to be practical, and it has to follow also practice that's also already used in the construction. What we do here is we track the biomass carbon. So we don't track all building materials. We are carbon sink standards. So we look for the biomass. And you will see how this is in fact possible without being too troublesome. All processing steps has to be accounted for their greenhouse gas emissions. And very important step here is that all greenhouse gas emissions caused from the removal to the construction site, to the inclusion of the carbon sink material in the construction, all greenhouse gas emissions that are caused by using the carbon sink material must be offset. Otherwise, this sink is not a sink because it's part of an emission sink scenario. So once we offset the emissions, we know the sink is in the overall climate balance a sink and can be used to compensate either legacy emissions or as temporary sink current emissions, or as a geological sink offset for a very long time greenhouse gas emissions from other sectors also. We have a material processor. So we go from the biomass, we have a processor who transforms the organic carbon material. This processor has to be registered and is controlled. The control is done by an essential by key player within this certification scheme is called the C-Sink Manager. We do have the C-Sink Manager in all our standards. And the C-Sink Manager is what's usually controlled by carbon standards and their control organization, CERES. They are endorsed, but they are like managing the entire process, that all the data that are necessary are provided, are recorded, and they take the responsibility that everything works fine. Uli Steiner and also Andy Kelly will certainly talk more about the C-Sink Manager. So I just mention it here that this is the turning plate of the entire process. And all C-Sink materials are labeled and entered into the material index, as said. And then each construction unit will be registered with all C-Sink materials. And then and I will delve a bit deeper into this later. The construction unit has to be controlled. So and that was a headache problem. Now you build a construction and you say this is a sink, but what happens if, let's say, the wooden house burns and is transformed into CO2 again, or construction is demolished? Then there would be no sink anymore. So we require a remote control, which can be done by satellite and is just purely automatic. It's just verifying that the building is still there. So we only certify carbon sink materials that are in the building envelope and that are hard to remove. So it would not be the table, the kitchen table that you can carry in and out, but it's something that will stay with the house. So when we see the house is still there and is not transformed, we can assume that the sink material is still in the envelope, which is an easy control, a cheap control, but it helps to not certify anything into the future, but a carbon sink that is certified ex post, as is required by most of the standard requirements. Okay, so we go a little bit further. What are C-Sink materials? We said already we had some examples coming from straw. We also mentioned biochar. It can be compressed cellulose paints. It can be oils, can be latex. And we will see in several slides further that there are classes that we look, classes of C-Sink materials. Very interesting. Future carbon sink for buildings is carbon fibers. Carbon fibers that were made from CO2 removed from the atmosphere and transformed into methane, and from methane to methanol, and from methanol to carbon fibers, which would be the perfect carbon sink, replacing steel, armor that could be replaced by carbon extracted directly from the atmosphere. So this carbon would not be biomass carbon, but it would be removed carbon or recycled carbon dioxide from the atmosphere, and it could be included in this standard. Now, as many of you come from the biochar world, already know that biochar can be certified as a carbon sink in building materials and as a geological carbon sink when it is included in the building material. Which means that the carbon from biochar that's included into the building will survive the building. However, you have other materials like wood or straw or bio-oils that will not survive the building. That when the building is demolished, it may decompose when put to waste sites, or it may be burned in the recycling process, or it may be transformed into biochar. So that means that at the moment of the demolishing of the building, you can start a new carbon sink. So if you recycle the wood from your building, you can prolongate the carbon sink of the wood in using it in a new building material. So it does not necessarily end there, but it has to be controlled at the moment of demolition, what happens with the carbon sink materials. So in the register, they can be prolongated if they are used in another carbon sink way. But for the moment, they are certified for the life cycle of the construction. So we have temporary carbon sinks from biological materials, and we have geological carbon sinks like from biochar or carbon fiber from atmospheric CO2. So we have this emission portfolio, as mentioned. Emission portfolio means that all emissions for the production of the carbon sink material are registered there and must be offset. This is a task of the carbon sink manager to do this tracking and recording. In most cases, these are standard values. However, for biomass production, we will see we already have certification scheme that can be used here to prove this. So one requirement for when using biomass as feedstock for carbon materials is the feedstock must provide carbon neutrality. So that means you'd not be allowed to clear cut the forest because you would destroy a carbon sink. So that would not be a carbon sink if you use the wood from a clear cut forest. However, if you only cut the regrowth from last year or from last 5 years from this forest, then this would be considered carbon neutral. So you find the definition how biomass materials can and are considered carbon neutral, and this is similar to how we control and certify feedstock for biochar production, for example. So we have here this 8 or 9 general feedstock classes, including synthetic carbon from direct air capture and CO2 recycling. So we have biomass from annual cropping, and we have biomass from pluriannual or perennial cropping like forests. And you will see how this leads to different controlling procedures. Now you get the biomass and you transform the biomass. So whatever, chipping, milling, drying, using conservation agents, burning the outside of the wood, or whatever happens, and whatever energy is used that produce greenhouse gas emissions must be accounted for. So this usually is, again, task of the C-Sink manager. So he makes the procedures, and as these are standard material, you can collect this data at the processors within the application, and it is normally not too much of an administrative burden. Then we already talked about the material index. So here you find data that must be entered into the index. So you have a material ID, and you need, and here it becomes a bit tricky. You need the weight of the construction C-zinc material per unit, and you need the carbon content. So in order to calculate the effective carbon included in the building material, you need the dry matter of the material. So here, these are procedures that are sometimes a bit difficult to implement at the processor when he's not used to. We see this also from biochar production. Still today that companies have difficulties to measure dry matter of biochar, but when you analyze the material, you get the carbon content as percentage of the dry matter. Now, if you only guesstimate the dry matter of your material that is, for example, 10 kilo heavy, but contains 5 kilogram of water, then also the carbon content would be a simple guesstimate. And that is not acceptable. So sometimes this seems the most difficult thing, to enter the carbon content of the dry material. So you have a material unit, let's say 1 brick, and 1 brick, we need to know how much carbon is in this brick. Now we can multiply it because we use 5,000 of these bricks, right? So the unit would be brick. And that's what we find at the construction site. So if we don't know how much carbon on a dry matter base are in these bricks, everything will be wrong in the end. So these are really important points. So that's what I try to explain with this slide again. So you get this material idea of your construction material. You have this RFT code, and at the construction C-zinc, your material is labeled, and everybody at the construction site knows this is certified carbon zinc material. Now he can enter it in the application, and that should not take more than a few minutes per rather big carbon zinc material unit. So we said the building is the carbon zinc. So it's not the material as such, but the building with all carbon zinc materials. I think this is the essential point of the entire standard. However, because the building is the C-zinc, the carbon that's included or used for the construction must be protected from decomposing. So that means if you have a non-treated organic material that you use in the insulation, and water and sun would penetrate, this stuff would go away pretty quickly. So this has to be in a matrix that protects the material from decomposing. The material must not be replaced or demolished before the end of the declared lifetime of the construction. So we have average lifetime. That seems super short, like for industrial buildings, 20 years and others 60 years. This is the average lifetime of the construction. However, because we do the remote control, the building will be a zinc as long as evidence is there that the building is still there. However, if you modify the construction, you do a renovation, this has to be declared, and therefore is also on-site control in 0.5% of the cases per year. So there is also control to check not only remotely via satellite imagery, but there might be a controller coming along, just verifying that the materials are still there and everything is declared in a correct way. So mobile materials such as wallpaper and movable walls and parquet and carpets and doors, they would not be certified under the construction carbon sink standard, which does not mean that they are not carbon sinks. They are also temporary carbon sinks. They would be certifiable under the material carbon sink standard, but cannot be certified under the construction sink because it cannot be verified how long they are. However, as you know, we have a spectrum of standards that work one with each other, and as soon as the material carbon sink is ready, standard is ready, that can also be certified then, but this has other requirements. So we already said this is ex post certification, so only what is put to evidence that it was there for last year is a sink for last year. Then you have at the construction site, when you put your C-Sink unit into the database, into the register, there are some data that you find in the standard. We have already talked about the C-Sink unit. And which is interesting is that the C-Sink unit as such is in the carbon standard. We have an emission portfolio. So we have the carbon sink registered of the C-Sink unit. We have all the emissions that were caused for the construction of the unit, also in the register. So we have an emission portfolio, we have a sink portfolio. And it would be possible to include also future emission, like for heating, electricity, air conditioning, and so on, during the time of use of the building. This is not a requirement, but this is a possibility. So as you can see, we try or we want to make buildings that are overall climate neutral and that stay climate neutral for the entire time of their use. We talked about the building control. Will not go into details of C-Sink options. So this is more about carbon credit trading, because we have to verify that the sink is still there and it was there for last year to make a temporary carbon sink out of it. There is still the possibility that you can trade carbon sink options, which would be the right to use the climate effect of the sink in the future. So that means if a carbon sink, you have a carbon sink option of 20 years, that means that in 20 years, you would have the right to use this construction sink to compensate temporary carbon emissions. To go in more into details here would require more time, and we will talk about this in later workshops. So I come to the end. There are certain data, and most of it is automatized through the applications that has to be entered into the global carbon register. And I will finish just with one example, how in fact we imagine the main use of this kind of temporary carbon sinks. They can for sure also be sold to others, but ideally they would be used to make the construction unit climate neutral. So just to give an example, if a building that was constructed in 2020 and caused 100 tons of CO2 equivalent as emissions, and now the building has a wood truss presenting 20 tons and straw fiber insulation with 15 tons, and then there's biochar for 50 tons, which adds up to it should add up to 100. It doesn't. It's only 85. So let's say there are 15 more tons in the basement. So you would have 100 ton of carbon sink that would be there at least for the 60 years that this building exists. And you have 100 tons that were caused by the building. So now you are climate neutral, 100 against 100 for 60 years. That means the building is climate neutral for 60 years. When you demolish it and then you burn the wood, for example, and then only the 50 tons of biochar remains, you would cause, after 60 years, 50 tons of emissions, which would have to be compensated for. But until this moment, so for the entire lifetime of this construction, the construction would be climate neutral, which would already be development in the right directions, and it would be the important message that we make constructions that are climate neutral, and then we recycle them at the end of their life cycle in a way that avoids any emissions. And then we keep it climate neutral. Now, I think this would be the way to use the construction C-Sink standard. However, there is also the possibility to just register these carbon sinks and sell them to someone else who is more eager to compensate its emission. Thank you very much. I hope I kept my time and happy for any discussion. Thank you, Patricia.
Thank you very much, Hans-Peter. We already have a few questions, and you didn't keep your time, so I will shorten down this question round a little bit, but there will be time at the end. So there is one question from Martin. You can raise it now. You need to unmute yourself if you want to ask your question now. Okay, then we will skip this Martin first and start with Lukas Romanowski.
Yeah, hello. Thanks for this presentation. Can you hear me?
Yes.
Okay, great. I have a question regarding the last topic you addressed. So as I understood, the carbon sink is registered for the lifetime of the building. I'm not quite sure what does this mean from an LCA perspective. If I make the LCA for construction, shouldn't be then this considered in the C stage of the building? So if I go to demolition, because then in the demolition stage the registration of my carbon sink ends, or is it not included in the LCA and it's then included in the next step when the owner of the building decides to demolish, and then it's his topic to solve this question? It's not clear for me who will be in charge and who has to address this topic. Maybe you can explain that to me, because yeah, that's a question in my mind.
Yes, absolutely. I mean, this is super important, and it also touches the current building code, because normally it is already included here. And we think that this is not correct, because we don't know the technology of recycling. in the average 60 years, probably even longer. We think, as we wrote in the biochar construction chapters, that in 50 years from now, carbon dioxide emissions from waste incineration will be recycled or has to be recycled, which means if you account today for those emissions based on our technology today, this is not correct. So yes, we go our own way here, and I mean, no, we suggest to go a different way. We don't go our own way because what we only do is the certification of the C-Sink. We don't say what the building owner or the carbon sink manager has to do with the sink. We suggest that the best use of it would be to compensate the building emissions until the end of the life cycle, which does not mean you have to do it. So let's say this is like our outlook, how we think building certification should go on in the future. So yes, we think we should look at the emissions when they occur and not account them 60 years in advance.
Thank you. We had some more questions in the chat.
Thank you.
Sorry. Was it answering your question, or do you have additional questions to this?
If I'm allowed to ask a following question, it's not. So I think the answer is not long. Are you already in discussion with, let's say, certification institutes for construction like DGNB or others, if they would accept that, if they would be willing to accept that?
This is a question to Uli Steiner, who will talk.
Okay.
He is the one, and Patrizia also, but she pushes us to do all this, and yes and no. So for now, in fact, in all the building codes, that there are. They account for, at least for wood carbon, right? And wood carbon is also difficult because of the NDCs, and the accounting is difficult. And especially when you want to deduce the sinks from the emissions, to declare less of the emissions. And that's not what we do. We only certify how much carbon is there and control that it's still there. And then it can be used by different standards, this system, to better account for the sinks. So it's an invitation, or it's also an offer to other building certifications to use, let's say, a more advanced certification of the carbon sink as such. But we don't do, in fact, building LCAs. This is not the offer.
Okay, thank you.
Patrizia, we had in the chat we had two questions. One from Mr. Bürgi, I suppose from Swiss Post. That's maybe one for Hans-Peter. So the question was, how do you ensure your construction wood is not originated from a clear cut? The most common practice in harvest method is to clear cut. I think Hans-Peter can answer that very easily.
Yes, so it's not so easy. Let's say it's easy to reply, but it's not so easy to implement. So normally, wood has to come from certified wood. That's how we do it also in the biochar C-Sink. So the forest exploitation has to be certified, and like with FSC, that would not allow clear cutting normally, which is not always the case, and we all know that normally clear cutting is the normal way, and this is also really the trouble within all that, especially when you import the wood, then it becomes another problem. So the answer is it's about forest certifications. It's only when wood comes from a certified forest it can be assured that this is not from clear cutting. And the same is, I didn't mention it, so if you have annual biomass, then the farm has to be certified by the Carbon Standard Farm Tool or farm certification to have the climate balance of the production from the annual production. So it has to be linked to other certification schemes. Otherwise, you cannot control it.
Thank you, Hans-Peter. There is one more question in the chat that I identified for now. That's the question. I suppose the C-Sync method will be aligned with the embodied CO2 values in the EPDs. Is that correct?
Yes.
The EPD values may still differ over different EU countries, but will be harmonized as part of the CPR in the upcoming years. And then there was an additional question or an amendment to this question saying it's a good question. In EU, the CRCF can be calculated in EPD performance. Can that only be done if C-Sync method is in line with or replaces the CRCF?
Yeah, it has to align with the EU ordinances. Even if in some cases we may like to deviate, it's just it's our internal requirement that this has to accord, and the carbon the material index will be aligned with all those values to calculate the carbon sink value of the material.
And maybe Hans-Peter, what you already mentioned is that the emissions of the C-Sync has to be offset, right? So, and there the EPDs are super important to understand what is the actual C-Sync of the material and what is also the emissions to produce this material, right?
Yeah, so the EPD that allows us to, well, it facilitates the emission accounting. So what is accounted for the emissions that has to be offset, that these values come from there, while the carbon sink value as such, they are not defined in other standards, and they are from the construction C-Sync standard.
Herr Kaisers, you want to add on this, right?
Yeah, I'll keep it short, but I'm actually coming from the other end, from the LCA side. We're currently running a working group on the whole life cycle GWP prediction of calculation. And really the big thing, I think, for introducing more bio-based materials or biochar in the concrete will be if we start accounting for the storage. And at this moment, every country except France has the -1+1 calculation methodology. So when you do the calculation for the 50 years according to the known WLC calculation, actually it's zeroed out over the lifetime of the building. And well, if we can somehow align more of the C-Sync activities in the whole life cycle predictions, that would, I think, be great for the use of these materials in the construction sector. But we're not there, so that's really look for possibilities to join that or at least bring it in somehow.
Yes, thank you. I mean, completely agree. So in our experience from developing standards in the last 15 years is sometimes we have to go several steps ahead when other standards or lawmakers are not there yet, because they need more discussions and compromises than we need to put forward something new. And then within this process, I think we are an inspiration also to the lawmakers and to other standards. And over the first 5 to 10 years of such a standards, then there's more and more alignment to it, and we align, and others also align, and in the end we should have a good compromise. So that's the objective behind doing this work.
Okay.
Thanks.
Thank you. I think that's a good endpoint for this question round, and I would like to hand over to Uli Steiner from CSI.
Thank you very much, Patricia. Let me share my screen. I hope that you can see my screen already.
Yes, we can see it.
Good. Let me give you some information in the next 15 minutes about how the construction ceasing standard can be applied operationally. And let me start immediately with an example that I would like to follow. We have here the first building from Openly. Andy Kale, he will inform you in detail about it. And I would like to pick one material out here. It's the hemp brick that we have in the facade and in the building himself. And I would like to explain to you how it works, and at the end also how you can start using the construction ceasing standard in your environment and have a look in the construction ceasing tool. I would like to come back to the image that Hans-Peter did show you already. On the left side, only here in this example, we have the production of the hemp in an agriculture environment. Already there we have differences. As example, if you have an organic producer, we have different emission factors than if you would have the emissions factors in a conventional organic production. And then we jump over to the ceasing material index. I will show you this also in the tool. In this case, the hemp brick stone would be registered in the material index, including some basic requirements, as example, the destination or some kilometers of transportation or some specialities. And all of this we will have in the ceasing material index as a basic source of data for creating the ceasing unit. If we jump over to the construction site, the construction will be certified, and certified based on the embedding of the material, of some verifications, if the material was really embedded, about the quantities, and also the emissions and the ceasing values will be verified for then register the ceasing unit in the registry. It's already on the right side of the image, and the issuing of the ceasings. That means in general the procedure is not so complicated, and the emissions have to be monitored. And I would like to come back to one question, I think, from the chat. Different DMRV systems, digital monitoring, reporting and verification system, can be used for this supply chain verification. And also in other standards, we have the system that these DIA-MAR-VIS systems can be endorsed by Carbon Standards International and then used for this tracking if necessary and if needed. In this example of a hemp stone, the production is a little bit special. Things has to be checked and verified, and at the end, the material can be registered in the material index and in the CSync unit. There were also some questions in the chat about existing data sources. We have the EPD framework in the EU, and we have Ökobaudat as one really important data source. And in Switzerland, we have KBOB as an important source of data of building materials. And these data can be used as a kind of basic layer of information to build a material index. To come back to the example of a hempstone, these data were not available, not in Ökobaudat and not in KBOB. That means it was necessary to calculate this and to enter the proper values in the material index for this producer that I will show you in the example. But it's important that we use existing data sources. It's not our plan to do something new, to create new databases. It's not the approach that we have. The system is then really simple. We have the material index, the hemp stone. We have the embedding process. We have the building as a CSync. We have the registration of this building. And then we have the building in the global CSync registry, the construction, and the construction as a CSync with different details. As we have the emission portfolio, as we have heard. We have the CSync values, as we have heard. We have some additional parameters, as example, the reporting and monitoring interval, in which time period it has to be checked if everything is still in place. All of this is part of the global CSync registry. A really important role, Hans-Peter mentioned already, is the CSync manager. If you go through the standard, you will find out that the CSync manager has a really important role, starting on the material side with the material index, checking of some materials not already listed, monitoring of emissions, at the end, registration of construction in the registry, and also transfer of data in the global CSync registry. It's an important role. The CSync manager is close to his constructions. He knows all the details about it. He has the knowledge for doing this job, and it's a really successful model that we have also in other standards already included. And I think probably Andy Kehl can also give some additional information. Openly is the first endorsed CSync manager in our standard ecosystem. Now, how do you start? The start is quite simple. If you think that you have buildings, constructions, and you are interested in going for certification, then the first option is, and it's the most simple one, that you collaborate with Openly, because Openly is an endorsed CSync manager already. If you think that, let's do that by myself, you can apply for an endorsement as CSync manager with Carbon Standards International. As we have the system also in other standards, it's always a possibility. The more simple way in the beginning, of course, and with the knowledge of Openly, is to collaborate with Openly directly. After this registration, you will get access to the construction CSync tool, and many of the work, many different steps of the work can be done directly in the tool in collaboration with other C-Sync managers or in your role as your own C-Sync manager. The construction C-Sync tool is a tool part of the EasyCert Cloud family that we have. It's well embedded in a bigger software tool environment, and it's as we have also in our other standards, World Climate Farm tool we have seen for the calculation of emissions, as example on the farmer level of to come back to the example of the hemp straw, organically produced or not. We have also other tools as Global C-Sync tool and others as carbon standards, or the Academy tool for online trainings. You will also find the construction C-Sync tool then here. And yeah, we have a first version of the tool, and I would like to demonstrate you a little bit how it will look like. It's not the final version yet, but we always start with the first version of the tools and then in the process of standard development. And as soon as we have the version 1.0 of our standards, we add all the functionalities. Yeah, you will find in the tool, we now jumped in the first version of our demonstration tool, more information about how the construction C-Sync standard works, about C-Sync materials, also as example about the construction as a C-Sync, about C-Sync units, also some examples how the things are calculated and all the different informations here. Then, of course, also important information about the C-Sync manager, because it's a quite central role in the system. And you will also find all the procedures for the registration, certification, online trainings directly online in the construction C-Sync tool. Let me jump over to the material index to give you an impression how it will look like in the daily business. Here, let me come back to my example. We have a hemp brick, and let me jump in and probably scroll a little bit to see it better. We see here the material idea, as Hans-Peter mentioned, material name, category, the manufacturer, the carbon content of organic carbon per unit, the material units, and many other material index details of this specific material in the index. Of course, you can jump in directly to the producer's website to find out more information about, as example, in this case, Schönthaler. And here you find then the C-Sync potential also registered as one important data point, and also the GHG emissions that are not compensated already per unit. And as we have heard before, the GHG emissions of this material has to be compensated in the process of certification. More information about this material, and here many different materials will be listed in the material index. And then we jump into the construction to come back to the example, the first building of Openly AG. We can see then more details, not only images and pictures and locations with the exact location and Google Map details. We have again the information about the materials embedded and the quantities. In this case, we can see 39,000 kilograms of hemp bricks were used in this material, in this construction, as one of the materials embedded. Emissions and compensation as one important element, the emission portfolio. We see CO2 emissions of C-Sync materials embedded with 120 tons. And we can see then, yeah, the first part of the compensation was done by the biochar applied in this construction in the building, 59 tons. And then the second part of the compensation was done with biochar sinks, but not from the building, from the CDR market. And then we see net emissions, C-Sync materials, 0 ton of CO2 equivalent. That means we at any time have the overview between GHG emissions of the construction and the net emissions of the C-Sync materials, and also some more details about this portfolio. Economic efficiency is an important information. We should have the possibility to calculate also some economic efficiency values. And that's what we do here in this chapter. And here we can see as example, we have carbon sinks with a duration of 60 years. And we will have also CO2 compensations of 100 years or 1000 years, it depends. And at the end, the economic efficiency. Here also you will find information about documents of this construction. You will find information about the PDD and how the PDD can be developed in a most as simple as possible way. And more information about this construction you can find in the construction tool here. Only as a first inside look, and different functionalities will be added over the next weeks and months here. On the level of the pricing, if we speak about the application of a standard, it's always important to have an overview about the prices. If you know the pricing of carbon standards already a little bit, then it's not something really complicated. We have annual fees for a C-Sync manager or a C-Sync trader with 400 euros per operator, and we have then labels fees for global C-Syncs registered in the registry, and some verification fees. And of course, there will be additional costs for endorsement, validation, verification. And what we will prepare for you is a calculator for the economic efficiency, for the costs that you can calculate quite easily if this construction with the materials that you plan to embed will be economic efficient. And also, as example, Andy will help you here to organize all of this. As a outlook from our side, and it was already mentioned before, we also have the plan to offer some additional webinars, and you will find also the dates here already then in the presentation for market and monetization, registration, and at the end, operational processing of the standard and C-Sync registry. And the next steps, what will follow on our side, also we will keep you here really informed. You at any time you can get further information, and you can also already register for the global construction C-Sync certification with us, or also with Openly. And we will do a publication of the standard in the version 1.0. We already got different feedbacks. We expect to get more feedbacks based on this webinar, questions, standard amendments, and we will include all of this in the version 1.0. And then in a later stage, you will have the possibility to get access to the construction C-Sync tool and also certifications. And this depends all a little bit now from the adaptations that we will do in the standard, from different topics, also feedbacks based on the webinar today. And we will keep you informed about the next dates and when everything will be available also for you as a user of the construction standard. For us, it's important that we build more constructions as C-Sync. We have seen the chart in the beginning of Hans-Peter, how big the potential is. And let's see that we can achieve this goal based on our hopefully very well applicable global construction C-Sync standard. Thanks for your attention.
Thank you very much, Uli, for letting us know how everything looks and what is developed so far. Looking at the time, I would like to directly jump to the next presentation and have the questions afterwards. So, Andy, the stage is yours.
Okay. I hope you can see my presentation.
Yes, we can see it.
Thank you very much for this opportunity to present the view of a construction site, but also the view of a C-Sync manager. Okay. So on the agenda, sorry, I kind of lost it. So on the agenda, I will talk about three things. One is the use of biogenic building materials in practice, because this is, let's be honest, not common nowhere on the globe. Maybe the most well-known is timber construction, but there are a lot of other building materials which can be used. That this can be scaled and can be used, I will show you with the pilot project Wittnau, Valley Wittnau, and then I will talk about Milton Earth. My background is I have a solid academic background, and I have already 2 times founded a company in the real estate sector. And my motivation to do all this is simply because I believe in net zero, and I want to make a difference or want to contribute to the global move towards net zero, towards climate change. It really matters. It matters for the whole global society. So when we talk about construction, what is super important to understand, I mean, I know in this audience I'm talking to converted, but nobody really realizes how big the emission portfolio of construction new build is. It's 25%. That's basically 8 times the whole air traffic we generate over a year, or 8 times the whole shipment. So every container coming from China or going to China, like every ship, every warship, everything is, the construction is 8 times more. So what we really need is a decarbonization of the buildings, of the building materials, and that means we need to change the way how we build buildings. We also need to focus on renewable building materials which grow. Uli mentioned the hemp, for example. It's growing in 110 days. So isn't it fantastic that you can grow something for 3.5 months and then build a building with it? That also means a local sourcing, or a local orientation, and also an adaptation in our processes, how we build buildings. I saw that we have some really big players from the construction world here, from Germany, from France, in this call. So it's on us to change it. And we started the work 2 years ago. This is the standard. We basically went with the documents from Hans-Peter Schmidt and Uli Stein, not too bad, like almost every day. But this really matters. So this is blood and tears, this standard here. So when we talk about negative building materials, I'm just pointing out 3 materials. The most important one is for sure timber, mass timber. We have about 720 kilograms net CO2 storage per cubic meter. And another one we already talked about is hempcrete, cork insulation, but there is also cellulose, bamboo, etc. As a rule of thumb, you see it here on the slide. If you build a building with timber, like a mass timber building, you can take as a rule of thumb 0.2 tons C-sink, net C-sink per gross floor area. That also matches the values we generated in the Valley Vinau project. Talking about the project, we achieve a net zero balance. I will talk about it in a second. It's the largest hemp house, so all the walls, everything is made out of hemp. For the load-bearing structure, we used wood and steel. There we used steel beams, which came from reuse, and we have basically developed a whole new construction system, and we are providing this construction system as a service or as an idea pool or as a Wikipedia globally to interested investors and construction companies. We already have 4 projects ongoing in realization for further projects, and in pipeline, especially in Germany, we have over 3,000 units. What is super important to understand is when you're using biogenic building materials, you're also saving CO2. So when we look at the CO2 balance from the pilot project, we have achieved about 900 tons of avoidance. So meaning by not building with concrete and a lot of glass and so on and materials, we avoid about 50% of the emissions. And this is super important in the whole journey of net zero. It's always first avoid and then compensate. So the avoidance part is super important. That's also for removal buyers. One major point that they're not just buying carbon dioxide removals. So they are not buying just removals. They are also causing an impact on the avoidance side. The avoidance side is not part of the standard. I think after an hour in this call, this has become very clear. To understand, it's like today only France and Denmark are moving with their CO2 targets. We have some movements in Germany, we have some movements in Switzerland and in other countries, but basically only France has committed to a 30% reduction and Denmark has implemented. So Denmark wants to establish by 2029 6 kilogram, 4.8 kilogram CO2 threshold for building a building. And this is super ambitious. I will show you the CO2 balance of Openly. So when we take today's, for example, the German target value is about 12 kilograms CO2 per square meter. And we achieved around 7.988 kilograms per square meter for the standard measures. But when we look at the effective figures we achieved, so we will arrive at around 6 kilograms CO2 per square meter. So meaning today with the construction system, we already meet the target of Denmark in 2029. And then, of course, we have the carbon removal. this 552 tons of valley Wittnau. And when we deduct this value, we almost achieve net zero. We don't talk about net zero for the building system because we are looking in the carbon removal as a separate part. I think also in the chat from the last hour we saw several questions going through pointing in that direction. So to summarize, it's basically a view on avoidance and on focus. And avoid basically means concrete, avoid concrete as the main issue of CO2. But of course also plastic, thermocell, glues, materials, metals, and so on. And on the other hand, we need to focus on lively neighborhoods, on plus energy. This is also openly, we produce more energy than the whole building consumes, and reduce like the building measurements, means build as less house as possible, and also reduce the window frame. So I don't want to go deeper into that. I'm just like to give you an overview how this all fits together. Talking about now the certification process. So basically, the idea is that a builder, a developer, a wood construction company, so someone who is going to build a building, is approaching a C-Sync manager. Openly is one C-Sync manager, but there can be many, also many in a country, in a region. So this is open. You can become a C-Sync manager of Carbon Standard International. And then we will, based on the submission to the government, so the Baubewilligung, based on that drawings and on a IFC model, so an ArchiCAD model, a 3D model, we will do a preliminary certification. So we are going to do an estimate of how big the C-Sync will be for this building. And we will also set up with Milton or other like CDR buyers already a purchase agreement, so that we would say it's like we would pay, for example, 120 euros per ton for carbon removals out of this building project. This is super important that it is before the start of the building, for two reasons. A, it's helping you to finance the project. It has kind of a mezzanine financing character. And secondly, it makes sure that in point of the additionality, that the buying of a CO2 certificate is really towards climate change. And then you basically build the building. And then again, with the final drawings, which you submit to the authorities, we do as a C-Sync manager, openly is the first C-Sync manager, we will do a final assessment and make an entry in the C registry, which you just saw from Ueli Steiner. So the carbon credits will then be edited in the carbon registry, and can then be traded or retired in case of your insetting. Important is that the money flow, so if you sell the certificates, the money flow will be after the entry in the global C registry. Hans-Peter Schmidt already mentioned it. Ideally, in an ideal world, we would use the credits for an insetting or for an offsetting of the building itself. An insetting is super interesting. For example, if Novartis is building a new headquarter or a new office building out of wood, they could use their own carbon credits for their own offsetting of their operational CO2 emissions. Or you can sell them on the voluntary carbon market. You're completely free because you, as a building owner, are the owner of these CO2 certificates. And here comes Milton into play. That's currently an Openly brand, maybe becoming a subsidy of Openly. So we basically provide the market liquidity or the market, the CDR market for those CO2 credits. And this is probably the most important slide for most of you in this call. So today, or we start now, as of this summer, to purchase the first or to certify the first buildings. And as I already mentioned, you can calculate about 0.2 tons per square meter, which is the C-Sink. And we will provide about around 120 euros per ton in market liquidity. This means about 1% of the construction cost. So in Germany, you build with 3,000 euros per square meter. In Switzerland, it's maybe a bit less than 1%, but in other areas, on other global areas, this could be like 2 or 3 or 4% of the construction cost, this 30 euros per square meter. And that's basically the whole scenario to understand like also to understand that we have the C registry with Carbon Standard International, but we also need a market because just doing the CO2 certification doesn't bring us or doesn't bring the biogenic building one step further. You have two contacts. One is Dr. Christopher. He is leading the certification team of Openly. He also worked a lot on the standard. He's super well known. He can also do LEED certifications or SCR calculations, etc. And on Milton's side, on the market side, it's Claudia from our team, which you can gladly contact for any questions or concerns. So that was my input so far.
Great. Thank you very much for showing us such lively how that can look in practice. Are there questions directly to Andy Kehl? Otherwise, while people are still thinking, in the chat there is still a question that wasn't answered during the presentations, and that is, how does CSI see the financial additionality in construction C-Sinks? Let's say local government bodies make regulations compulsory for one of the C-Sink materials. Will it still be eligible to certify for construction C-Sink or LCA from that point?
Probably, Patricia, I will start answering this question. We do not see any bigger problems on the level of financial additionality because it can be expected that if we are using more sustainable materials, as example, if you come back to my example, a hemp brick, then we will have more costs on the way of construction of building this building, and it should be possible to find the proper argumentation. What we can say that additionality in the C-Sink environment in general is a little bit a complicated thing. because it should be the case that we can make money with what we are doing. And it's sometimes a little bit difficult to find the argumentation, but here with construction, we see it as a good opportunity, and we will find the argumentations, the arguments for.
Yeah, maybe to add, wood is and other organic materials were always construction materials, right? In the history of construction, and if you look to Switzerland, people like to build their chalets with wood. So wood is a building material. Before. Now, what means additionality is if you look to the exponential curve of built environment that increases while the use of organic carbon materials does not increase in the same way. So the argument here is that if we do not provide incentives to increase the organic carbon content in the built environment, this will decouple. So I think that's also how we discussed it with the Swiss Department for Environment, that this is the main argument for additionality, is the construction material increases more than the use of organic carbon-based materials in construction.
Great, thank you very much. There is another question from Mahida from Equilibrium.
Yeah, hello. Hi all. Hi Hans, Yuli, Andy, and Patricia. So Hans, thanks for answering that. And Yuli, for you as well. I was wondering, see, what's the incentive for? If you could explain, like, what's the incentive for using biochar? More permanence carbon in form of biochar using in construction material, which is termed for only, as I go through the standard, I can see only for terms for only 60 years of permanence. So what's the incentive for us? Like, I hope you got my question.
Hans Peter, can I hand it over to you?
Well, the organic materials, if you do not transform them, you lose less carbon. So let's say a 60-year or 100-year wood carbon sink in a construction preserves more carbon than a 100-year biochar carbon sink in the construction. So there's more sink in not transforming too much the carbon material. So what is the incentive is, does the biochar make the concrete better? Because you would not put sawmill waste into the concrete, because it has more carbon, but it does not make the concrete better. So I think all the materials that we put on the list, and all materials Andy was talking about, in fact, make the building a better building first. And secondly, it makes it a carbon sink. So the main incentive is to create a fantastic building that's recyclable, that has a good living environment. So I see quite interesting. I just wrote an editorial about this subject, that because of the discussion of climate effects of certain materials, we tend to forget that most of those materials, they have an intrinsic value to be used, be it in agriculture or here in construction. So we should not forget about this when talking about the climate. So what is the main incentive? I think the main incentive is to make a great building, but I may be wrong here.
Maybe I can also add here or jump in. It's, you know, it's like the pilot project we have here in Wiedenau. It has a humidity of 40% in a winter heating period. So, but since this is not a standard nowhere on the globe, we live in new buildings which have 20% humidity in winter, and you need and people really suffer, or it's not good. But we have incentives like Minergie or Kuenge or whatever to build those buildings. So what I'm saying is today we have created or subsidized buildings which are harmful to the environment by causing high CO2 emissions, and B, are not best in class. And when I talk to professional investors, they usually always start with the question is, yeah, but it's more, do I get subsidies? Maybe. What else? It's more expensive. Why should I build it? And when you answer with it has a higher living quality, it has a higher value at the end of life cycle. It's designed for disassembly and so on and so on. Today, actually, nobody cares, right? This is the truth in the capitalistic market. But like everything started also with Openly, not with making money and starting a CTR startup. It started with proving or pioneering that biogenic building materials can make a difference. So this is the underlying.
Yes, and the carbon sink accounting is part of showing this and helping in fact to make a more livable and better building environment.
Yeah, and it's also interesting that this is also a question today in the chat, is that the DGNB or in Switzerland SCA, they're not helping in this discussion at all. They're actually sleeping, and that's the truth. And that's why we have to move, and that's why I'm also super proud of the work of Hans-Peter and Uli to come up with this standard, because it's so important that we have those values and that we have a value, right? That we can say Wiedenau is 522 tons of C-Zinc, right? And today we don't have this accounting method at all, nowhere on the globe.
Yeah, thanks guys for answering. You know, I couldn't agree more with you, Andy Keel, that these people has done a very wonderful job in putting up this standard. One feedback that I'm concerned about, you know, again the point coming back to biochar. When I speak about biochar, I mean somewhere in the LCA of building, even if we feel after 60 years, if the building is, or 50 or 60 years, after the building is collapsed or demolished. So if there is any method that we can state for using the collapsed material to landfill, or doing generating some methodology for that, so that we can increase the permanence of carbon, as well as ensure that the carbon is sequestrated. So that's the main aim, right?
Yeah, probably let me answer here. This is, I think you have seen it also already part of the global biochar ceasing standard, and also in the ecosystem, in the same time part of the construction standard, that in the special case, if you apply the biochar to concrete, this is already part. And for other building materials, probably this will follow. That we have different possibilities of certification, but we can jump in also deeper in a separate session if you are interested in.
Yeah, so the biochar is described as the, let's say, the persistent fraction of the biochar will survive the building and will survive the application of the building material to a landfill or to recycling into a new building. So therefore, the biochar carbon sink is considered geologic the moment you mix it to concrete. So that's the status today about the biochar. And as Uli said, here we have several standards, and they work together. So if you want to use biochar in the building material, it has to be EBC certified, and it will be also certified as biochar ceasing, and this corresponds to the construction sink. So like the farm, if you grow wheat or hemp, the farm has to be certified as the World Farming Tool. So we try to keep the standards lean. So like normally they should be below 50 pages, but then it corresponds with other standards. So for example, we would not deal with biochar carbon sink certification within the construction standards. This is dealt with in the biochar standard. But it's already there, and it's already a geological carbon sink once it's mixed to concrete.
Thank you for this clarification. I would like to have one last question and then wrap up the webinar. Angela Wiebeck, you can ask your question.
Yes, thank you. Thanks so much, Uli, Hans-Peter, Andy, to this very interesting introduction, I guess, to the construction ceasing standard. I think, Hans-Peter, you made a comment at the very beginning I found quite profound. It had to do with if even just 20%, I believe, of our concrete emissions were reduced, if we were able to do that, we could solve climate change. I don't know if I'm maybe misquoting you, but it was a pretty profound sort of insight into how powerful it can be in the construction sector for us to, to tackle this, whether it be through Openly and what Andy Keel has done, or through other biogenic materials. Yet it's not something we hear a lot about. We hear a lot more about CCUS, Climeworks, especially here in Switzerland. I'm sitting in Switzerland. I just wonder, can you maybe compare this type of standard versus, CCUS, and also maybe give insight as to what it is that we can do to get the awareness out there and to actually mobilize capital in this direction?
Yeah, if you allow, Ili. So I think it pretty much links to CCUS. So what I said is if 20% of the upcoming construction materials would be carbon sink materials, that would be like half of what is needed. What is not accounted for is that the 80% still emit and increase the emissions, So we cannot save climate change in continuing building, even if we increase the share in carbon materials within the construction. So it's, we also have, even if we put 20% of carbon sink materials into concrete, we have to reduce the emissions of the remaining 80%. That was Andy also showing. And most of the emissions are from concrete. And another very big problem is the very, very short life cycle of these constructions, 20 to 60 years. It's incredible, you know. You build a bridge, and after 60 years you have to destruct it and do a new bridge, which is super waste of resources. Now, if you put carbon fibers from CCU, so from ducts, for example, Climeworks CO2, or from waste incineration CO2, you put carbon fibers instead of steel, which would corrode. So the carbon fibers do not corrode. So this bridge will be there in 2,000 years, or let's say in 200. So you save to rebuild this bridge 3 or 4 times. And because you use CCU materials, so there's the really big potential in recycling carbon and using it in materials. And this becomes more technical. But in the end, it becomes cheaper. And regarding additionality, if the CCU in replacing steel armor in concrete receives carbon sink money, it becomes cheaper than steel. So in fact, CCU will become cheaper than the current economy. And that is what we work most on today at Ithaca, to create these scenarios, and this construction C-Sink standard is part of this. But CCU will probably be the most important carbon source, and not biogenic biomass carbon, I think. Today it's biomass carbon. The next 30 years it will be more CCU carbon. Sorry, Patricia, I again
No
talked too
worries.
long. So now we are
No,
1 minute
I just
over,
want.
but
No, it's good. It was very good last words, I think, to see the outlook and to see how these all standards work together, and what's the vision that Ithaca and CSI are working on together with Openly. So I would like to express my warm thank you to the presenters, Uli Steiner, Andi Kehl, and Hans-Peter Schmidt, for making the webinar happening today. And to everyone who participated, I would like to thank you very much for listening and enriching the webinar with your questions. I would like to remind you that the public consultation for the standard is still open for the next 2 weeks, so you can participate with all your inputs there. And we will have webinars every 2 months now until October. The next one will be at the 18th of June with Claudia Feuerstein from Milton Earth. Anybody else wants to have the last word now? Uli?
Yes, please, Patricia, thank you very much. Thanks to the audience for participating here. I think it was really important for us to launch and give more information about this newest and fresh construction C-Sink standard. And it was great to have this discussion today. And thank you for joining. And I wish you a wonderful evening.